temporary pump room. These are all flow serve pumps. Each one is rated for about 235 cubic meters per hour. So we've got a total of 9 pumps going here. Close to 2,300 cubic meters of pumping capacity in this area alone. Okay? Now, just go through a few key points. The underground water management is to ensure the continuous safe operation of the mine in case of the largest estimated inflow. That's very key that we do have that capacity plus spare capacity. And that works out to about 2,500 cubic meters of pumping capacity. That includes that spare capacity, almost twice the capacity required to deal with an inflow. The ROM area is part of the process area. From the jet boring machine that you saw this morning, the cuttings goes to the ROM area, run of mine. So we have the south and the north. And basically they are storage areas for the cuttings from the jet boring. That's recovered by the clamshell and put into the crusher, which goes to the ball mill, and then from the ball mill goes to the clarifier, which adjusts the density for pumping or going to the ore slurry hoisting system on the 500 level, which will pump it directly to surface to the slurry loadout. Okay, any questions on that? So we'll just proceed up in here. I want to give you an idea what the interior of the ROM area will look like. The cuttings will go either in this ROM or at the other end behind another concrete bulkhead. Clarifier adjusts the density of a slurry. Okay, so what we're doing right now is we've done the additional ground support, cable bolts, screening, shock rating, and we're putting the monorail in right now. Once that's done, we'll muck out the next level, do the ground support, and then take out the final cut because there's actually a little bit of a ramp going down here and clean that up, and then we're ready for construction in this area. This is where number 2 shaft will break through. First off, let's look at the freeze system that we have in here. For those that aren't familiar with freezing, we bring the brine down at approximately minus 38 degrees Celsius, and it goes through the manifolds here from the heat exchanger. The pressure in the manifolds is about 100 psi. That's key when we talk about the heat exchanger when we get there. Again, it's for safety reasons that you have it about 100 psi. Now you have along the back 23 holes, if you count them going around, and you see they're all like that there, and that freezes the perimeter around number 2 shaft all the way up to where we started sinking again at approximately 390 meters below surface. So you've got a line going in and a line going out. The line going out then goes to the next hole, so you always got 2 holes in series, and then goes back into the return line to go back to the heat exchanger. Now this was really quite effective. We were seeing freezing in the area within about 3 to 4 weeks, and I believe it was about 6 weeks until we were able to start shaft sinking. So now, key to the shaft sinking is the tubbing. And I'm sure most of you are aware of the tubbing that's used in the potash mines where they go through the Blairmore Formation, and that protects them from potential inflow. We assessed what different options we had for securing the area, hydrostatic liners versus tubbing, and we came up with the assurance of success was tubbing. So we're doing tubbing all the way down to just above the 480 level. And that's a long-term solution to any potential inflow from the number 2 shaft area. we have the heat exchangers here, so we have a low pressure system on the level, approximately 100 psi, and then we have the high pressure system that goes into the shaft and up to the freeze plant. The efficiencies are very good. It comes down at about minus 38 degrees, and it only loses 1 or 2 degrees in the heat transfer. And the brine going out to the areas goes out about minus 37, coming back around minus 34, minus 35 degrees Celsius. Okay. Now, of interest, all this has been done since we dewatered. We had to take all those heat exchangers to surface and have them refurbished in Saskatoon and then brought back underground. This is one of the 6 bulkheads for the 465 level. It's approximately 8 meters deep, tight filled right to the back with concrete. And then the holes that you see, the pipes that you see in here, were used to grout it and seal off the perimeter of around the bulkhead. So this is a hydrostatic bulkhead that we have in place, and we have 6 of them to deal with the 465 level. Okay, this is 737 Crosscut North. This is our first freeze-hole drift, and done by the tunnel boring machine. We've refurbished the whole area now, and if you look down there, you can see the feed and the return line for the freezing, and then you can make out the rubber pipes, insulated pipes that are going up to the boreholes going into the back, or freeze holes in the back. Very similar to what you saw underneath number 2 shaft area. And this concludes your tour. We're back at the shaft. Very proud of the achievements that we have done over the last several years since the inflow, and we're really focused on getting the project done on time and safely.